We've seen how to determine the slope between 2 points when we have a graph in front of us, but an equally important skill is to be able to calculate the slope when we have the coordinates of the points in front of us and perhaps not the graph. I have the graph here as well just to reinforce our understanding of what slope means. But a student should be able to calculate the slope given 2 points and no graph in front of them. Now, what's motivating the calculation is, again, the understanding that slope is a change in the y direction divided by our change in the x direction. And what's important to remember is that a change, as represented by these lines here, is really a distance. And one way we determine distance is by subtracting values. So while certain educators will have students remember a formula, I tend to like to have students stack their points and simply remember that slope is a ratio where the change in the y distance is put in the numerator and the change in the x is put in the denominator. And so we can see that if we want our change in our y, I'm going to label the coordinates x, y, because sometimes students are tempted to just subtract the x coordinates first and put that on top, probably because we have this bias of moving from left to right. But remembering that slope is change in y divided by change in x, we can do the subtraction 3 minus 1 rather, which is our change in our y. And notice that's really describing this distance right here. And in the bottom we would have negative 2 minus 2, and that's describing this distance here at the bottom. But not only is it describing the distance, there's a sign indicator as well. So it is important that if I start by subtracting 1 from the 3, in other words starting at the top point, I have to make sure that when I'm subtracting the x coordinates, I also start at the top, or else I'm going to get this sort of the complete opposite of what I really want to calculate. 3 minus 1 is 2. Negative 2 minus 2 is a negative 4. And so we have the slope represented as 2 minus 4. Now that might seem strange because in my diagram I have that you're moving from the left point to the right point, and you're moving down to, not up to. However, if you simply start at that point and decide to move up to and to the left 4, you would indeed end up getting another point that's on this line. Okay, so this is not inaccurate. This is a completely legitimate way of representing the slope. However, this negative is allowed to move anywhere. It can be moved to the front of the fraction. It can be moved to the top, or it can be kept at the bottom. Moving it at the top, you can see that we'd be interpreting the slope as moving down to and to the right 4, and that we can describe by representing this change here in the picture as moving down to and then moving in the x direction from left to right, right 4. But the point is, I use the phrase stack and subtract to help students remember how to determine the slope between 2 points, or how to calculate the slope between 2 points when you have the coordinates of the points and not the graph in front of you necessarily.